Hi folks, we're going to take a look at page 83, number 17b. So they give us this parabola here, and they want us to find the equations of the tangents that pass through the point 2, -7. So the first thing I notice here is that if I stick 2 into this equation, I get 2 times 4, 8 plus 3, 11. So this point is not on the parabola, okay? But we know that the tangent lines, okay, have to pass through that point. Okay, so just to get a sense of what this might look like is let's draw ourselves a picture here. So let's say, our parabola I guess would look something like this, just translate it upwards. Okay, and here we've got our point 2, -7, so somewhere here. And it stands to reason that there would be a line that passes through this point, okay, and would be tangent to the parabola. Okay, but when I think about it, there might be a second line which passes through that point, which would be tangent to the parabola. Okay, so we need to determine the equations of these lines. Okay, so we know a point on it, 2, -7. Okay, and we know that these two lines are tangent to the function 2x² + 3. Okay, so we know that the derivative of this function gives us the slopes of the tangents. So y prime equals, well, derivative of this function, 2 times the derivative of x², which is 2x. So 2 times 2x is 4x. And then here, derivative of 3, that's just a constant, so that's 0, plus 0. So this function gives us the rate of change, or the slope, at any point on the curve for its tangent line. Except we don't know at what x value we'd be calculating that slope. So we can't find the slope explicitly here. Okay, but let's use the fact that the other way in which to find the slope of a line is to use 2 points on the line and use the difference quotient to calculate that slope. Okay, so I don't know what this point is, so I'll call it xy. Okay, now that point, is also another point I don't know, so the xy could also be on that side. So it looks as though I'm looking for 2 points. Okay, I can't see any possibility of drawing another tangent to get a third one, but it looks as though we're looking for 2 points here. Okay, so xy is 1 point on the line, and 2, -7 is another point on the line, so I can write an equation using the slope formula. So the slope is 4x, and that's going to be equal to the difference in the y's. So y minus -7, so y plus 7, over x minus 2. Okay, and now I have an equation that, well, I can't quite solve this because I've got 2 variables here. But remember, xy is a point on this parabola. So I know that the y value can be written as 2x² + 3. Okay, so I can simplify this equation here by replacing the y value by 2x² + 3. Okay, and now I have an equation that I can solve. Okay, so let's go ahead and solve this here. So let's cross multiply. So here I've got 4x times x minus 2, so that gives me 4x² minus 8x. And then here 2x² plus 3 plus 7, 10. Okay, and yes, I have an equation in terms of x, but I have a quadratic equation in terms of x. And I know quadratic equations can possibly have up to 2 answers. So that sort of justifies this idea that I saw graphically, that there might be 2 answers to this problem. Okay, so let's solve this here. So bring this stuff to the left-hand side. So 4x² minus 2x² is 2x² minus 8x, and then minus 10 equals 0. Okay, I can simplify my life here by noticing that these are all divisible by 2, so I'll divide both sides by 2. So this becomes x² minus 4x minus 5 equals 0, and this looks like it factors pretty easily. So x minus 5 and x plus 1. And so x is either equal to 5 or x is equal to -1. Okay? But of course, they weren't just looking for the x values at which this occurs. They're looking for the equations of the tangents. Okay? But now that I have these x values, I can now find the y values. So here, let's stick y into the, stick 5 into the original equation. So 2 times 5 squared, so 2 times 25 is 50, plus 3, 53. Okay, and here let's stick -1 into the equation. So 2 times -1 squared, which is 1, so 2 plus 3 is 5. Okay, so now I have this point on the line, okay, and I just have to determine the slope, and the slope, of course, is given by 4x. So here the slope is going to be equal to 4 times 5 is 20, and here this slope for this line is going to be equal to 4 times -1, -4. Okay. Now, just as I was solving this, I realized I don't actually need to find the y values for these x values, because I know that these lines both contain the point 2, -7. Okay, so I really only needed the x values here to calculate the slope. So I did a little more work than I needed to. Okay, no big deal. Okay, so let's now find the equation. So for line 1, so since this would have been the more efficient way of doing it, let me use the point 2, -7. Okay, and the slope of 20 here. Okay, so let's calculate this here. So -7 equals slope of 20 times x value of 2 plus b. So here we've got, this is 40, so -7 minus 40, -47. Okay, so my equation is going to be y equals 20x minus 47. Okay, and now for my second line, okay, I'll again use the point 2, -7, since it's also on the second line, and the slope of, what was it, -4. Okay, and here we've got y equals -7 equals -4, my slope, times my x value of 2 plus b. So here we've got -8. So bring it to the other side, we have -7 plus 8 is equal to 1. So the other equation is y equals -4x plus 1. Okay, I certainly could have used these points also, but again, the more efficient way would have been to use the point given. Okay, so just to recap on a question like this, okay, because we don't know at what x values we're finding the tangent, okay, we had to use this idea of calling the point on the curve where the tangent is being considered, okay, as a variable point xy, and then just using my slope formula to come up with an equation that I can solve. Okay, and don't forget that if you have a y value in an equation for a function you know, you can always replace that y value by its expression in x.